हेलो गाइस, वेलकम टू माय चैनल। आज के इस वीडियो लेक्चर में हम मल्टीमीडिया नेटवर्किंग एप्लीकेशन पढ़ेंगे। Multimedia networking application. We define a multimedia network application as any network application that implies audio or video. In this section, we provide taxonomy of multimedia applications. We will see that each class of application in the taxonomy has its own unique set of services, requirements, and design issues, but therefore before dividing it into depth discussion of the internet media application, it is useful to consider the intrinsic characteristic of audio and video multimedia themselves. Properties of audio. Perhaps the most silent characteristic of audio is its high bit rate. Video distributed over the internet typically range from 100 kbps for low quality video conferencing over the 3 mbps for streaming high definition movies. To get a sense of how briefly consider these three users each using the different internet application. Our first user Frank is going quickly through photos posted on his Facebook post page. Let's assume that Frank is looking at new photo every 10 seconds and the photos are on average 200 kbps in size. Our second user Martha is streaming music from internet to her smartphone. Let's assume Martha is listening to many MP3 songs one after another, each encoded at the rate of 128 kbps. Our third user Victor is watching the video that has been encoded at 2 mbps. Finally, let's suppose that the section length of all three users is 4000 seconds stable. Compare the bitrate of the total by transferred for these three users who is see that video streaming consumed by far the most bandwidth having the bitrate of more than 10 times greater than the Facebook and म्यूजिक स्ट्रीमिंग। हम इसमें देख सकते हैं कि जो वीडियो की बैंडविड्थ है ना वो फोटो और म्यूजिक से कई गुना ज्यादा है। Therefore, when designing a network video application, the first thing we keep in mind is high bitrate requirement of video. Given the popularity of video and its high quality bitrate, it is perhaps not surprising that Cisco predict that streaming and stored video will be approximately 90% of global consumer internet traffic by 2015. Another important characteristic of video is that it can be compressed, thereby trading off video quality with bitrate. The video is a sequence of images typically being displayed at constant rate, for example, at 24 to 30 images per second. An uncompressed digitally encoded image consists of an array of pixels with each pixel encoded in a number of bits to represent luminance and color. There are two types of redundancy in videos, both of which can be exploited by video compression. Spatial redundancy is the redundancy within the given image. Intuitively, an image that consists of mostly white space has high degree of redundancy and can be efficiently compressed without significantly sacrificing image quality. Temporal redundancy reflects repetition from image to subsequent image. If, for example, an image and a subsequent image are exactly the same, there is no reason to re-code the subsequent image. It is instead more efficient simply to indicate during encoding that the subsequent image is exactly the same. Today's off-the-shelf compression algorithm can compress a video to essentially any bitrate desired. Of the course, the higher bitrate, the better the image quality and better the overall user viewing experience. We can use compression to create multiple versions of same video each at different quality. For example, we can use compression to create say three versions of same video at rate of 300 kbps, 1 mbps and 3 mbps. User can then decide which version they want to watch as a function of their current available bandwidth. User with high-speed internet connection might choose the 3 Mbps version. User watch the video over 3G with smartphone might choose the 300 kbps version. Similarly, the video in video conference application can compress on the fly to provide the best video quality given the available end-to-end bandwidth within the conversing user.